All right, welcome back everyone to the third tutorial that we're doing this year. So the first tutorial we did an introduction to NFL data with R, and the second tutorial we did like data viz with R, like getting really good at making scatter plots, bar graphs, tables, all that stuff. So if you type in like mfans YouTube to Google, you can like find the first two tutorials right here that were recorded a month ago. And then if you also want to get the code for this like current tutorial that we're going to be working on today, you can come to my GitHub page and you can find the NFL tutorials 2022 in Google and then click on this. And then that also has some comments where you can find the first and second tutorials as well. And then when I upload this video to YouTube, the third tutorial will also be labeled here on the GitHub. So, since some people learn this way, I'll I can put that in the chat as well. But basically what we're going to be doing today is we're going to be doing linear regression modeling. So we're going to start off and make a logistic regression model to predict whether or not a team will go for it on fourth down or not. And then we'll make a linear regression model to predict whether or how many air yards a quarterback will attempt to pass for, depending on all the game situation factors. So these are very basic, modeling techniques, but they can give us some pretty good prediction values if used correctly. We're not going to go like super detailed into kind of like the background behind logistic and linear regression and like the types of things that you're supposed to do when you work with those, like scaling your variables and stuff. Today, we're just going to be going on like a quick overview of how to do this type of stuff. And then we'll be back in 2 weeks doing some random forest and XGBoost. So some tree-based modeling to kind of take our modeling techniques to the next level, but this will just be a basic start. So to start, I realized last time I didn't show how to open a R script. So, if you click the top left here and where the plus and you click R script, then you can get a notebook to work out of because you don't want to really be typing stuff in the console. So you can just type it from the front there. So we're going to want to load in our tidyverse package that does all the functions that we have, our NFL Fast R package, which has all the data and teams, colors, logos that we need. And then this might be a new one that you might not have installed called VIP. So remember, if you don't have a package installed, just do install.packages and VIP. But I already have it installed, so I'm not going to run that line. So the VIP package will tell us the variable importance of each of the variables in our thing, and then we're also going to want to load the GG image package so that we can do plot, a team logos plot. So again, to run it for those who don't remember, maybe this is your first tutorial that you're watching, you can highlight the line, you can just put your cursor there. If you're on Mac, you can do command return. If you're on Windows, you can do control enter and get that, or you can highlight and click run here as well. And that will load in all your packages. And you'll see these aren't error messages. These are just things that are saying which packages they're attaching on when you load in something like tidyverse or anything. So don't really worry about those. But once you have your packages loaded, and then we can load in our play-by-play data. So again, this is a function that comes from the NFL Fast R package. So you can do load in play-by-play, and you can see it says NFL Fast R loads play-by-play seasons from the NFL Dataverse repository. So we'll take 2018 to 2022 just to give us a couple of years of data to work with so that we can build our logistic regression model. And again, it will give like a little message in the console, but you shouldn't really have to worry about that too much, as it'll load in the data fine. And so while that's loading in, we can create just a data set with just fourth downs in it, because we want to predict whether or not a team will go for it on fourth down based on what's happening in the game. And from there, we can decide if a coach or a team is aggressive on fourth downs or not aggressive based on what they do over what we expect them to do or under what we expect them to do. So again, we can do fourth downs, we can make our arrow, and then we can take our play-by-play. They say right there, and we can do our pipe, which I do from Command Shift M on my Mac. And then you can also do the old pipe if that's what you have set up for in your R Studio. Again, it depends. I have my R Studio updated, so I use like the new pipe, I guess I'd call it, but some people might want to use the old pipe as well. So if this doesn't work for you, make sure that you're doing the %, greater than symbol %. So from this data set, we can filter. And we're going to want to filter and just get fourth downs. And then we're also going to want to get it where we don't have any NAs for the play type. So we just don't want we don't want a play type that isn't like something that, maybe didn't happen. Maybe it was a data error. Maybe it was something that shouldn't have been logged in the right spot. So we can kind of get rid of those two things. So when you put a comma in between your two filter statements, that'll say that we're doing this and we're doing this. So it'll just get fourth downs and it'll take away the small percentage of plays, if any, that don't have a play type. And we can see over here in the top right that we originally started with 216,000 rows and we're down to 17,000, which makes sense. That feels like a fair amount of fourth downs to have happened in this time frame. So we should be good to roll with that. And I touched on the play type. So we can see kind of like what usually happens on fourth down. Like what do these plays get labeled by? So this one we don't have to put into a new data frame because we just want to see it displayed in the console. This is just a quick check by us. So we don't usually have to put those in the data frame. So we can do group by play type, and then we can put another pipe, and we can just do this tally method. So tally is really good for when you quickly just want to check how the count for each type of things. Tally is cool because you can sort it if you want, and it'll put it in order. But basically, we just want to see, all right, punts happen most of the time on fourth down, then followed by field goals. And then here are the teams going for it, number 3 and number 4, the pass and the run. And then we have some no plays. And so maybe these are penalties that were taken, either intentionally or unintentionally. And then we also have QB kneel. So, if we wanted to be really nuanced with the model that we make, we can maybe take out QB deals since that shouldn't count really, or we can look into why like no plays happen. Was it because if the offense was on the field, or did the punt team take a delay game? But we just want to get like kind of the method to modeling today. So we're not going to do all that. We're just going to create our model to start with. And so what we want to do basically is we have these two play types, pass or run, that tell us the offense or the team with the ball on fourth down passed or ran the ball. So we can create a variable, an indicator variable in our fourth down kind of data set where we're saying, all right, they went for it on fourth down or they didn't go for it on fourth down. And so to do that, we can use mutate to create a new column, and we can call our new column went for it. And we can do went for it equals, and then we can use our if else statement. So what if else does is it'll display here. If else will run whatever test we want it to do. If it's true, we want it to have a yes as an indicator. And then if not, we want it to have no. So we're going to say, all right, if play type is in, so this is kind of saying if play type is in, pass or run, we're going to create like a list basically. So we can see down here, pass or run. If play type is in, pass or run, when we create our list, we'll put a 1 for they went for it because they either passed or ran the ball, and then a 0 if they didn't go for it. So this finishes our if else statement. We can see right here, the other way you could kind of do this is if you wanted to, you could just do like play type equals pass or play type equals run. But when you have a really long list, like if this was like 5 things that we had to do, kind of using our percent sign in percent sign and then C, and then open parentheses and like the stuff that we had in the list and then close parentheses, it's kind of the right way to go. So now we can see over here, we started with 372 variables in our original data set, and we're up to 373 because we went for it as a column. So now this is, good practice to do and kind of gives us some practice with modeling. We're going to take our data set and we're going to see, all right, which variables do we think are going to correlate with whether or not a team went for it on fourth down? And then what kind of relationship does this have with it? So we can group by yards to go, because I think, a 4th and 1 is going to have a lot higher likelihood for a team to go for it than a 4th and 20, let's say. So count equals n. We can just see how many times this happened. Went for it. Rate, let's say, equals mean. And then we take the average amount of times that someone went for it because we have the 1 or the 0 there. Print that out in our console just to see what it looks like. And we can see that on 4th and 1, teams are going for it at a 57% clip. 4th and 2, that goes down to 31%. Then 4th and 3, 17%, all that stuff. But yards to go isn't the whole story. When we can even, yeah, we'll plot this one out just for fun. We won't plot the other ones, but let's just plot this one out just to see what it looks like. So we'll filter count greater than 5, just so if someone went for it on 4th and 40 because they were desperate, that doesn't throw off the percentages. So let's just get like the really low percentage counts out of there. So we can go into our ggplot from this, right? We don't necessarily need to put this into a new data set to plot it, because this is the data that we're working with when we go into make our plot. So we'll say, all right, X is yards per go, Y is the went for it rate in ggplot, and then let's make it a bar chart. So we can do, and we'll color it based on whether or not they went for it. So what we're doing here is we're saying, all right, the x-axis is yards to go, y-axis is the went for it rate, and then we're saying, all right, we'll take our geom bar, we have to do our AES to access any variables that we're using. So went for it rate is right here. And we'll say went for it rate. And then every time we make a bar chart outside of the AES aesthetics, we need to do stat equals identity. And then let's put a theme on our plot. Oh, not count greater than 5, not n. Import rate, not found. Wait, did I do something wrong here? Oh, okay. I need to change that to filter. There we go. So we can see in our plot here that it makes that, 4th and 1 has a very high go for it rate, and then it kind of levels off and then kind of bounces up and down, depending on probably like other game situation factors for the rest of it. But it is very clear that yards to go has an influence over went for it rate. So we know we're going to include that in our model, which is good. We can do the same thing then with a variable like yard line. So if we, group by yard line 100, like how we group by yards to go up here, we can summarize, count equals n, and went for it rate equals mean went for it. And then we can all, filter again on count, or basically typing the same code that we did. And then let's just like, if we wanted to, we can just copy and paste it here and make sure, copy and pasting usually isn't a good practice, but we can just do it and change it to yard line 100. So again, it's the same code from up here, and we can run that plot and open it up and kind of see how yard line affects it. So again, this is why, when we're making a logistic regression model, it's going to provide one intercept and one coefficient for each variable. So it's going to have a one trend here going from top to bottom. When we do our tree-based metrics or tree-based models in our next tutorial, this will be able to account for the granularity where it valleys when teams are in field goal range, and then it spikes when they're kind of in no man's land, and then valleys again. But that's just something today that we're gonna have to work with, but it'll be really cool to do that next week. So again, some of these also are influenced by win probability as well. So when we go and make our model, we're going to use what we call a GLM. So we can call our model log fourth, and then we're going to use a GLM from the stats package. So GLM it says used to fit generalized linear models. We can kind of specify what we're working on here, and it will take the variables that we have and put a expected probability that a team goes for it on fourth down or not. So to make this GLM, we take our fourth downs data set that we've been working with, and we went for it, and then the squiggly thing, because we're saying, all right, this is the variable we want to predict. Now, what are all the things that we can add to it? We can add yards to go. We can add yard line 100, which is how many yards they are away from end zone. And we should also add win probability, because if you're down a lot in the fourth quarter, you're probably going to want to go for it more, and that should account for that. And then we also need to say where our data comes from. So data equals fourth downs. So this will make a logistic regression model for us. So we can see if we print this out, this will give us our coefficients. So what is our intercept? So we start with 0.6, as kind of like a baseline for how likely a team is to go for it on fourth down. And then we can see that as the yards to go increases, the chance of a team going for it decreases, which is why yards to go has a negative intercept. As yard line increases, it's basically no correlation. As we saw in our plot, it's a kind of a bimodal distribution, so it's harder to get a good value there. And then as win probability increases, by one, then we expect that the probability goes down 0.32. So if we just start with the intercept and we plug, we go from 0 win probability to 10 win probability, we could expect this to go down 3.2% chance, basically is what that means. We can also take the summary of our logistic regression model and print that out. And we can open this up and see what it is. So here is the formula that we put in. Here are the residuals that we had. It's a little bit left-tailed, where we're predicting a higher probability than they actually go for it, which is okay. And obviously something we could fix if we had more time. And then we also see which values are significant to the model. So when there's a 3 stars, that means it's very significant variable, which is not super helpful when we're only working with 3 values, but could be super helpful if you're working with a lot of values and want a good feeling of how they interact. So that's kind of how to make a logistic regression model. And something I wanted to show that that we won't go into too much detail today is First I'll plot like the variable importance. So again, like this is more important when you're working with a tree-based model since you don't have set intercepts. But when you do VIP and then open parentheses log forth and then close parentheses, you can get a variable importance graph that shows, all right, win probability was our most important, close second, yards to go, and then third was yard line 100, which makes sense again because of the weird distribution that yard line 100 had. So when you work with linear logistic regression models, there's something called interaction facts that play a role. And what these are basically is yards to go and yard line 100 are correlated. So this will cause what's called covariance, which is, as your yards to go increases, your yard line 100 will also increase. So you can account for that by giving them their own separate slope when they're interacting with each other. But we're not going to use this model. I just want to show how to do it. So we'll call it log forth co. Again, we'll make our GLM. We'll do went for it as our indicator variable, and then we'll do yard line 100, yards to go, and win probability. But then to say that we want to account for interaction terms, we'll wrap this whole thing in parentheses and we'll square it. Oops. We'll square it. And then data equals fourth downs. So just to recap, GLM, indicator variable, went for it, squiggly, parentheses, yard line 100, yards to go, win probability, square it, and then data equals fourth downs. And we can just see, just so like, you can see what it looks like when we do our summary of log forth co, which stood for covariance. Now we can see these are interacting with each other. Yard line 100, yards to go are interacting with each other. So it gives you different slopes depending on how that goes. You could play around with that and like there's a formula and everything, but we're not going to work with that one when we end up making predictions, but it's just something useful to know. So now let's check if our prediction probabilities are doing a good job and kind of how they're laid out. So we take our fourth downs, or actually before I show you that, so log forth, which is the model that we're going to be using, when you put a $sign there, it has all of this stuff for you. Coefficients, which we looked at, residuals, which we looked at. But then you also have this fitted values, which gives you the probability for every single fourth down. So we're going to use this. So again, if we were doing this professionally, you'd want to split this into a test and train data set and train on the test data set and then test the fitted values on the test data set. But we're just doing this just to learn how to do a logistic regression here. So we're doing log forth on fitted values just to see what it looks like when it's plotted out. So we take our fourth downs and we're going to mutate a predicted probability. And that'll be the log forth fitted values that we just did below. We're going to ggplot and we're going to do AES x equals yards to go. We're going to make a geom smooth on the predicted probability. And let's make that black and size equals 2. And then we're also going to make a point for when they go for it or not. So this will be along the two axes and you'll see how that works in a second. So again, we're going to want to use our if else for our color. So if went for it equals 1, and let's make it a dark green to show that they did a good thing for the most part. And then if not, we'll make it a dark red. Let me put this down here. And then we can kind of put our alpha and make these a little bit lighter. And then let's put our scale color identity so that dark green and dark red actually show up. Let's put our theme minimum. And then let's label the X and Y axes. Yards to go. And chance offense will go for it 0 to 1. Let's plot it. Oh. Spell something wrong. Oh wait, did I do? Let me see here. Went for it, not found. Let's see. So if we redo geom point ASY equals went. Oh, I see what I was doing. Okay. I took the color out of the AES. That's actually good that I made this mistake. So since we're using went for it in the AES, the aesthetics, since that's from the data set, we need that to be in the AES. So that's why there needs to be 2 here, because we're using went for it equals 1 or equals 0. So that needs to be in the AES, not outside of it. Alpha is just using 0.8, so that can stay out of the AES, but that's the mistake that I made. So we can kind of see now when we have, the went for it, we can see that, depending on kind of like what our line thinks, it kind of starts here. And then once we get to 10 yards to go from the first down, teams have a very low % chance to go for it. And then like the problem with, logistic or linear regression is it doesn't know when like there's a 0, so it'll just keep going. So, what you can do is if we change this to geom line instead of geom smooth, we can kind of see, how this works as it goes down. So like the reason why these lines are so up and down is because yards to go isn't the only variable that we're using in this. We're also using like win probability and all that stuff. So that's why it's like affecting these, but we can see the general downtrend with that there. So now we can get 4th downs over and under expected. So let's do 4th downs into our 4th downs. And then we can, again, get the predicted probability where we get log 4th on fitted values. And then we can also do, all right, what's the 4th down over expected? So we can mutate again and we can get 4th down over expected. So it would be if they went for it minus the predicted probability. Run that. And now let's make a team plot for whether or not they went for it. So again, if we can open this up just so we can see this data set. And if we go all the way here, we can see we have our predicted probability that they'll go for it, whether or not they actually went for it, and then 4th down's over expected. So they had a 40% chance of going for this one. They did go for it, so their 4th down's over expected was 0.59. Here they had a 10% chance to go for it. They didn't go for it, so they had a negative 10. So let's just see if we were to just do the 2022 season, what their 4th downs over expected were. So we filter on 2022. We group by possession team. Oops. And again, for those watching on YouTube after this is week 8 that I'm recording this, so the results might be different. So you don't have to panic or anything if it looks like that. And then we can get the expected 4th downs that the model sees for them, we can get the actual forts for the like how they oh wait, sorry, went for it, for how often they actually went for it. And then we can also get their total forts over expected, which takes this fourth OE column that we made here and summarizes it. So we're grouping by possession team, summarizing, we're doing how many opportunities did they have, what's the expected fourth, what's the actual fourths that they went for, and then what's their fourth downs over expected. Let's open up this data set just to check. So let's see here. The Colts, Saints, Buccaneers, Steelers at the bottom makes sense for fourth downs over expected. The Lions, Eagles, Jaguars, at the top also makes sense for fourth downs over expected. So this seems directionally correct. So we can make our plot for this to get a good idea of which teams are going for it over and under expected. So we'll take our expected fourths to get a good feel of how often these teams are in situations where they should go for it on fourth down. We'll want to create an average line. So we'll do geom h line, y-intercept. Let's take the mean of team fourth 2022, which is what we call the data set, and our actual fourths. Line type equals dashed. And we'll do the same thing. We'll do the x-intercept. Line type equals dashed. So we'll do a horizontal line, a vertical line. So, I mean, we can plot this just to show which step is doing. So that's what this does. Nothing too useful yet. We want to make sure to see a trend line, right? So, and we want it to be a linear trend line. We don't want it to be kind of like a clear, smooth trend line. Let's do method equals LM. Its default color is blue, so we'll make it black because I don't like the color blue that they have for it, but obviously feel free to do that on your own. Size, let's make it a little bit bigger than the one that it usually is. And then we'll make it a little bit lighter. And then we're also going to want to get it rid of the standard error. Standard error is good to have if you're doing like straight up stats, but we just want to make a nice looking plot. So let's not worry about that. And now we can plot our team color logos. Oh, I just realized that up here, we don't have the team color logos in this data set, right? We just have the teams. So we need to left join teams colors logos and join it by host team equals team abbreviation, because for those that remember team colors logos, the column with each of their names in it, like Arizona, is called a team abbreviation. So let's join that in. And let's do image equals team logo ESPN. And then we'll make our aspect ratio and our size. Actually, we can make our size 0.05. So aspect ratio is like kind of like the dimensions that you want to save the plot in. 16 divided by 9. Size is how big you want the images to be. So you usually want to keep them really small. Let's add a theme. And then let's add our labels, and I'll type these up quickly since this is just like up to the viewer. So expected fourth down goes on the x-axis, put a comma. Actual fourth down goes as the y. Title, team, fourth down, actual, and expected. Goes, and then based on a logistic regression model. And then let's make our axis ticks look nice. So scale x continuous. Breaks equals scales. So we access the scales package and we get pretty breaks from there, which makes them look really nice. And then we could do the same thing for the y-axis. Breaks equals scales. And again, this is window dressing, right? Like the whole meat of the plot is these lines up here, line 74 through 80 on my screen, where you actually, plot the images. Like this is the most important line right here. The rest of this, oh, sorry, this is the most important line right here. The rest of this is just to show the trend line, kind of where the averages are to give you a good feel, all that stuff. So we can plot that, and then we will go on to our our linear regression model now that we've finished our logistic regression model. So we can see that the Cardinals have been expected to go for it a lot on fourth downs this year. They've been a lot of 4th and 1s. They've been down in a lot of games in the fourth quarter. Makes sense. The Chiefs have never been expected to go for it on fourth down. Basically, they're up in a lot of games. They, rarely have long yards to go, all that stuff. You can see, the aggressive teams up here, the conservative teams down here. This makes sense. There's a correlation between our expected fourth down goes that we created and the actual fourth downs, which is really good. So now we can go on to our linear regression model to wrap things up. So let's just we want to predict in a quarterback's air yards based on kind of similar variables that we just predicted a team to go for it on fourth down. So we want to take our play-by-play data set, and we just want passes for this one, right? And then we also want to get rid of plays where there's no air yards. So if they took a sack or if there was a penalty. If there was no down listed, so like if it was the special teams or something like that. If there's no win probability listed, we need to get rid of that as well, because that's a variable that we're going to be using. So we can just keep stringing together exclamation point is.na air yards, exclamation point is.na down. So it's a little bit of a tedious process, but we'll get there. And then is.na for yards to go, and then is.na for half seconds remaining. So we can run all of that. And we can see we have 83,000 rows here. And then we can check and make sure our variables are right. So, oh wait, hold on. Before I was supposed to run that, I was supposed to, let's just get a data set with just the variables that we're going to be using to build this model. You don't have to do this, but just easier to look at for errors. Because one thing we have to do is we have to take our down. A quarterback, it might not be linear what they do from first down to second down to third down. So what we need to do is we need to create a down column where down is a factor instead of a numeric number. See like how all of these variables right here are numeric, but down might not be linear because fourth down is totally different than third down, and like the separation between the two shouldn't have the same intercept. So we need to create down as a linear, or sorry, as a factor. So what we're going to do is we're going to take air yards down, win probability, yards to go, half seconds remaining, and we'll also take what season they're in. And let's mutate down equals as dot factor down. So it'll encode a vector as a factor. So to basically make down a category instead of a numeric column. So now if we do str, which gives us the play type, or the type, we can see that air yards is numeric, good, because it's a linear regression model. Down is a factor with 4 levels, which is good, the 4 downs. Win probability numeric, yards to go numeric, all that stuff, good. So we're good to go there. We also want to make sure that there's no NAs in our data set that we're working with, because that might throw it off. So we do call sums, which will sum up all the columns depending on whatever function you want. Is.na pass play model. And we can run that. We can see, all right, 0 for all of them. Is see if up here we were to just run pass plays without running the filter. Oh, I guess it's still 0, but some, usually you'll have some NAs there, so just have to be careful. But yeah. So now we can make the linear model. So for this, we're going to use LM. So that stands for, the linear model, and we can make our formula. So air yards is what we're mapping to. Down, which is our factor, wind probability, yards to go, and we're just going to keep putting plus signs between these. Half seconds remaining. And then another thing you can do is, I wanted to show here, you didn't have to do this as factor down. You could also do as factor in the actual function call, and it'll do the same thing. But I just want to show one of each method. So since season, air yards doesn't move linearly between seasons as well, we should also create a season variable, as air yards can fluctuate over time. And then we make our linear model. Let's get a summary of it. And we can open it up and see we're off by usually -6 to 4 yards. We can see which variables are important. So it's important for the model to know that we're in 2022 or 2021, but it's not important for the model to know that we're in 2019, 2020 based on the significance values that we see here. All these other things are important as well, which is good. And again, if you want to account for interaction terms, you would take this whole thing and put it in parentheses and square it, but we're not going to do that. And then, so now we can get our variable importance. So we can use the vit package. And if we plot that, we can see that how important each variable was. So yards to go, makes a lot of sense for, if for how many air yards a quarterback is going to have. We can also, downs 3 and 4 make more sense to be important. And what this did was it made the intercept down 1. So down 1 is first down is the intercept, and then the rest of the values are downs 3 and 4, and then half seconds remaining, because of Hail Marys and stuff. So all that stuff makes sense. So now we're going to get the predictions. So what we're going to do here is we're going to do air yards predictions, data.frame, predict.lm. So see this, we're going to predict based on our LM. And then we're going to do air yards LM, new data, which it's not technically new data since we didn't split it into training and testing, but it's good enough. So we run all of that. So what we're doing basically is we're predicting LMs, we're getting all these values, but right here, when I just printed this, it puts it into a matrix. What we need to do is put it into a data frame like this so that we can bind it together. So if we open up air yards preds, we can see, but it has this really weird column name. So what we're going to have to do is we're going to have to rename that column name. We're going to say, all right, expected air yards equals, and then we can get that column name from doing air yards preds $, and then copy and pasting that whole thing so that we don't have to type it out. Again, like if you need to copy and paste something, it's on the GitHub right here. So you can just like copy and paste that. But, if you just want to keep typing it out, make sure to do that. So run that. Now we have expected air yards for each play, but this doesn't tell us anything. What we need to really get to is we need to join this together with our original data set. So we can create a new data set called air yards projections, and we're going to column bind. So C bind pass plays with air yard preds. So these have to be the same amount of rows or else it won't work. We can see here, pass plays, 83,616 rows, air yard preds, 83,616 rows. So now we have air yards preds, which will have our expected air yards. If we open it up and go all the way to the right in our very last column, expected air yards. So let's get the air yard projections for 2022, and then we will be done. So air yards minus expected air yards, we're going to mutate. Oops. We're going to mutate the actual air yards minus the expected air yards for each one. We're going to want to make sure we're just getting the 2022 seasons. We're going to do filter equals 2022. Then we can group by passer name. So group by passer and summarize passes equals n. Expected air yards equals mean expected air yards. A dot equals mean air yards. So just get their normal average at the target. And then there's two ways to do the average expected air yards. We could just do A dot minus expected air yards. Because we created those two right here. And again, you have to have these before you do this one then. Or we could just take the mean of a air yards over expected, which we labeled that there. And then let's filter on passes and make sure we get over, let's just say like 140 passes, just so we're avoiding small sample size. So we can open air yards over expected up. So again, just a run through of what we did. We created our air yards over expected column, filtered it on 2022, group by passer, summarized, we got passes, we got expected air yards, A dot, average air yards over expected, and then passes greater than 140. And again, like if I were to run this summary, like the adjusted R squared on our model is 0.00. So it's not a good model that we're using. So like some of the results might be wonky. Like, again, if we were to use a higher advanced modeling technique, it might be better. And like linear regression model could be really good for something else. But for this specific thing, we don't have a good model. But when we check our average air yards over expected, some of the names make sense. We have Marcus Mariota, Justin Fields, Tua, Russell Wilson, Lamar Jackson, some aggressive quarterbacks like Josh Allen and Geno Smith are also up here. At the bottom, we have Matt Ryan, Matthew Stafford, Kirk Cousins, Justin Herbert, Daniel Jones. So this makes sense. What's really interesting, I think, is when you look at the expected air yards, Mahomes, Hurts, Allen, Tannehill, Lamar, quarterbacks that have been playing well this year, all show up really low, which is a good thing because if you're in low expected yard situations, that means you probably did a good thing the previous play. So that's all I have for today. Just to recap, we loaded in the play-by-play data, created our fourth downs data set, created our indicator variable, whether or not they went for it, looked at some variables that influence fourth downs, created a logistic regression model here. Then, created our plot that again, you can use using ggSave, as I talked about in one of the previous tutorials. You can create our plot, or sorry, create our second plot down here, which is what the team plot was. Then we went into our linear regression model, creating pass plays, creating our smaller data set, making down a factor column. So, so that down shows up separately. And then creating a linear regression model off that, getting predictions and putting those predictions into actionable insights. So again, I ended up making a plot for this here. I'm not going to get to because we're out of time, but again, all the code is on the GitHub. This tutorial was called 3 linear regression modeling. So just, feel free to go to my GitHub and look at that. And then for the people on YouTube, always feel free to give feedback and message me if you need anything on Twitter or email me or anything. Yeah, so before I stop the recording, does anyone have any questions, or I can stop it and then look at the questions after? Okay, cool. I'll stop the recording.